Okay, so we're done with how you are going to illustrate system of linear equations in two variables. So this day, we are going to have the graphs of a system of linear equations in two variables and their kinds. Okay, so we have to take note that a system of linear equations in two variables will always be written using the bracket, and then you are going to have two linear equations because system of linear equations is composed of two or more linear equations in two variables. Before we proceed with the graphs of the system, let us have a recall on the methods in graphing linear equations. Okay, can you cite some of those methods that we have before? Okay, so the first one that we have discussed is about the x and y intercepts, correct? Or I told you, it is also the same with Takip method, which cannot be seen in any source of materials. Next, with the second method that we have discussed is, correct, we have the 2 points or using 2 points. And then the third method that we have is using the slope and a point, correct? And the last method is we have the slope and y-intercept. Okay? So I hope you are all familiar with these 4 methods on how you are going to graph linear equations, and you have mastered any of these methods because this will be a great help on our next topic for this day, which is again the graph of system of linear equations. Okay, so we have this one, graph it. Determine the graph of equation by using x and y intercepts. Graph them in one set of Cartesian plane. So again, we all know that we have 4 methods in graphing linear equations, but this time I am going to use, or we are going to use, the x and y intercept. So if you have seen that the given equations have no coefficients from the variables, like this one, we have the coefficient just 1, negative 1, 1, and 1. So it is very easy if you are going to use the x and y intercepts. Okay? So I hope you already have your Cartesian plane beside you. Okay, so to proceed, again, you are going to graph the following system of linear equation for this given. Okay, so are you done? So let me help you. Using the x and y intercepts, I will cover the variable x for you to find for the y coordinate or the y intercept. So you will left here with negative y equals 2. But since we have here negative 1 as the coefficient of y, so you are going to divide both sides of the equation by negative 1. So you will obtain y equals negative 2 here. So you are going to plot y equals negative 2 on the y-axis. So since negative, it is on the lower part. So we will have here y equals negative 2 or 0, negative 2. Okay, question? Okay, next, let us have the x-intercept by covering the variable y. So now we left with x equals 2. So, we are going to plot x equals 2 or 2, 0 on the x-axis, of course, since it is positive. So, you are going to plot this on the right. So, we have here 2, 0. Then, after that, you are going to connect the points, and that will be the graph of x minus y equals 2. Okay, question? So, if you don't have your question, let's proceed with the second equation of the given system. We have x plus y equals 4. So again, we are going to find for the y-intercept by covering x. So we have left with y equals 4. Since it is positive, so you are going to plot this on the upper portion. So we have your 0, 4 on this part. Okay? Next, we have to cover up y. So you will find for x. So we have here x equals 4 as our x-intercept. So, x is positive. So, we have here on this part, we have x is equal to 4 or 4, 0 here. And then, you are going to connect the points. And then, do not forget the label. So, that green line is the graph of the second equation of the system. X plus y equals 4. Okay? So, this is now the graph of the given system. Okay? So, I have here the questions. What have you noticed on the two graphs? Yes, they formed two intersecting lines. Okay, what is the solution of the system? Okay, so let's check. So we have here two intersecting lines. So we have here the blue line and the green line. They intersect with each other. And since they are intersecting lines, so you may notice that there is a point of intersection here. Okay? And this point of intersection here is the solution of our given system. So what do you think is the name of this coordinate? Okay, so we have here, yes, so we have here 3, 1. Okay, and if you are going to check this 3, 1 on our equation of the given system, we are going to substitute 3 in place of x and 1 in place of y. So we have here 3 minus 1 is 2, which is true. Okay, on the second equation, let us have 3 in place of x and 1 in place of y again. So 3 plus 1 is 4. So 4 is equal to 4. So which is also true. If it seems that in the first equation is true, the second equation is also true, therefore 3, 1 is the correct solution of our given system. Again, this is called a solution of the system. Okay? Because it satisfies the first equation and the second equation. Because in the given system of linear equation, you may only say that the ordered pair is a solution of the given system if and only if it satisfies both equations of our given system. Okay? Any question? Okay. So I have here another example. So look at me now. So you are going to graph the following system again of linear equation. So for number 1, we have the system x plus y equals 3 and x minus y equals 1. So still, as I have said earlier, if you haven't seen any coefficient of the variables x and y except 1 and negative 1, it is better if you are going to use the x and y intercepts. Okay? So let us use that method here. So using the x and y intercept, we have here x is 0, your y is 3. So you are going to plot on this part. So we have y is equal to 3 here. And then, next we have to cover up y. So that y is equal to 0. And then you will obtain x is equal to 3. So x is positive 3. So we have here the point of x is equal to 3. Then, combine the 2 points and do not forget to label the graph of x plus y equals 3. And then, on the second equation, using again the x and y intercepts, so we are left here with negative y equals 1. So, your y here should be correct, negative 1 on this side. And then, we have here to cover up negative y or y, then you will left here with x equals 1. So, the value of your x is 1, positive. So, you will have to plot this on this part. And then, do not forget to connect the points and do not forget to have the label of the graph. And that will be the graph of x minus y equals 1. Okay? So, how can you describe now the graph of the given system? Yes, good. The lines are intersecting. Okay? So, if the lines are intersecting, the kind of system is what we call consistent. Okay? So, again, this is an example of consistent system. And as you have noticed, there is a point of intersection again. So, the two lines intersect on this part. Okay? So, what is the ordered pair that describes the point of intersection? Yes, so this is 2, 1. So, let us see if it is the correct solution. You are going to substitute 2 in place of x and 1 in place of y. So, 2 plus 1 is 3 is equal to 3. Correct. So, it is true. Then, on the second equation, 2 in place of x, 1 in place of y. So, we have here 2 minus 1 is 1 is equal to 1. So, it is also true. So, therefore, since true on the first equation, true on the second equation, again, 2, 1 is the correct solution of our given system. Okay? Since we have here the graph which are intersecting lines, so in the consistent system, you have to take note that, okay, again, in the consistent system, you have to take note that there is exactly one solution. Okay? Exactly one solution because that is only the point of intersection of the two graphs. Okay? Question in the first example? Okay, so let's have the second one. We have here x plus 2y equals 6 and x plus 2y equals 8. Okay? So in this example, I used the other method, which is the slope-intercept method, wherein you are going to rewrite first our given equation in the slope-intercept form. Okay? So we left here with 2y equals negative x plus 6. Then you are going to divide both sides or all the terms of the equation by 2 for you to eliminate the coefficient of y here. So you will obtain the first equation will be y equals negative 1/2 x plus 3. So our m here is negative 1/2 and our b here is 3. And that is, you are going to plot them first. So we have here b is 3 or 0, 3. So you are going to see that in the y-axis, of course. So you will have here b equals 3. Okay, question? Nothing. So let's proceed. For you to have the second point, you are going to use your slope. So again, you are going to use this slope. Remember that since we have negative 1 on the numerator, so from the y-intercept, you are going to count 1 unit downward. So you will have here. And then since we have the denominator 2, so you are going to run 2 units to the right because it is positive. So you will have from this 1, negative 1, and then we have here positive 1, positive 2 units. So this is the second point. And then that will be the graph of the first equation, x plus 2y equals 6. So do not forget to have the label. Okay, any question in equation 1? Okay, so if you don't have, let's proceed with the second equation. For our second equation, we have x plus 2y equals 8. So still we have to use the slope-intercept form. So it will be 2y equals negative x plus 8. Then you will have to divide both sides of the equation by 2. And then you will have here y equals negative 1/2 x plus 4. So this time, our m is negative 1/2 and our b is 4. So you will have to plot first our y-intercept b equals 4 or 0, 4. So since it is positive, it is also on the upper part. So we have here 0, 4. Then use again the slope. So you will have negative 1 unit. So go downward. 1 unit downward. And then since our denominator is 2 or positive 2, so you are going to count 2 units to the right. So 1, 2. So this will be the place for the second point. Then connect the points. Then label the points. And that will be the graph of the second equation. X plus 2y equals 8. So any question? Okay, so let's have the kind of system or the kind of graph first. What have you noticed on the given graphs? On the graph that we have obtained? Yes, the lines are parallel. Okay, so if the lines are parallel, so the kind of system is what we call the inconsistent. Okay, so again, inconsistent system. Okay. How about the number of solutions? Okay? So, in inconsistent system, since the two lines do not intersect, so there is no solution. Because there is no common point wherein the two lines will meet. So, that's why, if you obtain parallel lines, there will be no solution. Because that is an example of inconsistent system. Okay? Any question? Okay, so let's have the third one. We have x minus y equals 3 and 4x minus 4y equals 12. Okay, so in this system, you may use any of the 4 methods again on how you are going to graph. But let us try to use again the x and y intercepts here. Right? So if you are going to find for the y intercept, cover up x. So you will have with negative y equals 3. So you will obtain y equals 3. Then plot that point. So you will have here 0, negative 3. Question? Next, let's have the x-intercept of the first equation. So we are going to cover this y. So you will have with x equals 3. So you are going to plot x equals 3 or 3, 0 here. Okay? And then connect the points and label that as that is the graph of x minus y equals 3. Question? So let's continue. Using this equation again with the x and y intercept, so you will have to cover up negative 4y. Okay, or you may use also negative 4x first. Cover up 4x, then you will have with negative 4y equals 12. Then you will obtain, or you are going to divide mentally by negative 4, so you will obtain y equals negative 3. So therefore, you are going to plot here also negative 3. So we have yan. And then we have the x-intercept by covering negative 4y. So you will left with 4x equals 12. Then divide both sides by 4 mentally. So x equals 3. So we have here to plot here. 3, 0. And then connect the points. And okay, so we have now green. And that is the graph of 4x minus 4y equals 12. Okay. So what have you noticed now on our line? Yes, correct. That is, the lines are coinciding. So when we say coinciding, you have just obtained one line. Or in some books, you will obtain same line. Okay? And the kind of system, if you obtain coinciding lines, one line or same line, is dependent. Okay. So again, that is an example of dependent system wherein the number of solutions will be many or infinite. Okay? So when we say infinite, many. So because all the points that the lines lie will be the solutions of our given equations in the given system. Okay? So those are the kinds of our system. Okay? So to recap, we have here the graph of system. So intersecting, we have this form. When we say intersecting lines, the kind of system will be consistent. And the number of solution will be exactly one solution. Okay? Then next we have the parallel lines. Okay? So maybe this one or maybe this one. If the lines are parallel, the kind of system will be inconsistent. And the number of solution will be none. Okay? Or again, no solution. Okay? And the third one is coinciding, or sometimes we have here one line. Okay, so as you have seen on the illustration, sometimes it is called one line or same line, wherein the kind of system will be dependent. Okay, and when we say dependent, the number of solutions will be many or infinite. Okay, so you can count the number of solutions. Okay, so that is the summary of our discussion. Is there any question? Okay, so I have here the things to remember again. The intersecting lines are lines that intersect in a point or in exactly one point. When we say parallel lines, these are lines that never intersect. The two non-vertical lines are parallel if and only if they have the same slope, just like on the second example. And coinciding lines are two lines that lie on top of one another. Okay, so they will overlap. Okay, so I have here given, so you can try it now, for you to have the graph of system of linear equation. And then after graphing, you are going to state whether it is parallel, intersecting, or coinciding. Then give also the kind of system and the number of solution. Okay? So that's all for now. Thank you.